Welcome to Kieran and Winnie's circular motion experiment. Here we captured slow motion footage of a toy car speeding through a straight path in a loop, giving us a clear view of its circular path. We recorded 3 trials of each motion to ensure accuracy in our calculations. Let's break down the math behind this motion. To calculate the centripetal force, we first needed to measure the car's mass, the radius of the loop, the length of the flat track, and the car's speed as it traveled around the loop and the track. Starting from the top of the track, we calculated the potential energy, which is based on the height of the track. Here, potential energy, PE, is mass times gravity times height. In our case, that is 0.03608 kilograms times 9.81 meters per second squared times 1.16 meters, giving us a total PE of 0.4102 joules. The kinetic energy, or KE, equals 1/2 times mass times velocity squared, based on the car's mass and velocity. With an average velocity of 3.47 meters per second, the kinetic energy reaches 0.2172 joules. The kinetic energy is less than the calculated potential energy because air resistance and friction causes energy to be lost as heat or sound and the car to move at a slower velocity than predicted. Now let's focus on the forces within the loop. The gravitational force is calculated using Fg equals m times g. In our case, that's 0.03608 times 9.81, giving us a total force of gravity of 0.3539 newtons. Finally, using the formula Fc equals m times v squared over r, where m is mass, v is the speed within the loop, and r is radius, we find the centripetal force. Plugging in our values with a mass of 0.03608, an average velocity of 2.30 meters per second, and a radius of 0.1425, our centripetal force is calculated to be 1.34 newtons. This centripetal force is what keeps the car moving in a circle. Without it, the car would fly off the track instead of following the loop. Observing the car's real motion and calculating the forces behind it helps us understand how circular motion works in the real world. Thanks for watching. Stay tuned for more experiments that reveal the science behind everyday motion.